Hi, thanks for joining us today. At right are the graphs for a function f and its inverse f inverse. That's what that little notation means, f to the negative 1 power. Remember that if a graph of f has the point a, b, then the graph of f inverse has the point b, a. That means, this is the same statement, the graph of f inverse is a reflection of the graph of f across the line y equals x. So if we look over here at our graph, this crazy little graph, you can guess which graph it is, you can guess which graph it looks like. If we reflect it across the line y equals x, what we get is this graph, which again, you might be able to guess who that is. And this point a comma b, the point with the x coordinate a and the y coordinate b, becomes this point, b comma a, the point whose x coordinate is b and whose y coordinate is a. And that's to get by reflecting it across the axis. So from the graphs above, do you see a relationship between the growth, or should we say to the right for us, for this picture, do you see a relationship between the graph, the slope of the graph of f at AB versus the slope of the graph of f inverse at BA? I'll let you think about it. Pause the video, write down and answer. Literally write down something. 3, 2, 1. Most people end up saying, oh, I think the slopes are perpendicular. So let's draw it out. You know what? I'm going to use line tool. Whoops. That was dumb. All right. Something like this versus something like this for f inverse. Again, we're trying to draw a line that pretty much just glances right off. And I'm going to try to make them hit each other. See? So, are they going to intersect at a right angle? No. Everyone should be able to tell that based on how these two lines look. So they're not perpendicular. Are you revising your answer? All right, and now here, the real truth is that what happened was they are reciprocals. And that's the lesson of today. In these 3 videos, you will see that the slopes are reciprocals, not opposite reciprocals. So reciprocals, again, reciprocals is the part of opposite reciprocals where we flip the fraction, not the part where we flip the sign. Just to be clear, we are inverting the fraction. If this guy has a slope of, let's say, 1/2, this guy has a slope of 2, not -2. And that's what we're going to be talking about today, the derivatives of inverse functions and this relationship. So let's walk through an example. Slow speed. You should try to do this all. You really should. It's not that bad. Try to do one step and then watch that part of the video. Let me correct you as you go. Don't worry about doing it all, but try to take these notes. Try to go through this example. Try to think about what each part of this should say. If you've already done this and you're watching again, cover it up. Try each part again. See what you would get. Here we go. Did you pause it? Did you try to sketch a graph? 3, 2, 1. Well, I don't know much. Most people end up calling this something like a swoop, which is kind of ridiculous. It's a square root graph. The square root of 0 is 0. The square root of 1 is 1. The square root of 2 is some weird number. 3 is some weird number. But the square root of 4 is 2. I don't usually advocate graphing by points, but for this example, we are going to. Overachievers might notice that the square root graph is concave down. And now it's asking us to find F inverse. Did you try it? The way we get F inverse, the algorithm, is to replace f of x with x and replace the old x with a y. And we try to solve for y. In this case, you would solve for y by squaring both sides. But as the hint says, you must list a domain restriction. So this would be the inverse, but our domain has to be based on the domain of the original function. What were the x's allowed to be in the original function? They were allowed to be 0, including 0, including 0, up to infinity. And again, we can never include infinity, that's rounded. Did you get both of those? If you did, good job. If you didn't, why not? Try to be thoughtful, thinkful. Sketch this guy's graph. Remember with the domain restriction. 3, 2, 1. It's our old friend a parabola. If you graphed a parabola, it happens to share this point. It happens to share this point. And it happens to share, 2 squared is 4. Like that. And so what we might notice, again, that point was 2, 4, and this point was 4, 2. So just like with the intro example, whose graphs, by the way, this is a cube root graph, and this is a cube graph. This is a square root graph, and this is a square graph. What happened was the coordinates got flipped, got reversed, got inverted, inverse. All right, so far so good. Differentiate both. You should be really good at this by now. Hopefully you didn't integrate both. F prime of x would be 1/2, because this is x to the 1/2 power, times x to the negative 1/2 power. So, the worst part about this whole section, really, is what I'm about to write. So it turns out the only notation for this guy's derivative is f inverse, and then you prime it, and then the input's x. Is that awful? Yes. Is it hideous? Yes. But that's the only way about it, ladies and gentlemen. Is 2x, and again, it inherits the domain restriction from its original guy. Domain, we include 0, and we go toward infinity. That's it. So find the slope of f at 4, 2, the slope of the graph of f inverse at 2, 4. All right, so finding the slope of the graph of f at 4, 2 is f prime of 4. It's not f of 4 prime, it's f prime of 4, f prime of 4. So that'd be 1/2, 4 to the negative 1/2 power. Let's simplify that, shall we? 1 over 2, 1/2 power is square root on the bottom, which is 1/4. So the slope at 4, 2 is 1/4. Cool. I think it's cool. And then this again, f inverse prime of 2, we plug in the x coordinate, is 2 times 2, which is 4. So what's the relationship between 1/4 and 4? The relationship between 1/4 and 4 are they are reciprocals. And for the second time I will say they have the same sign. They are not opposite. They are not perpendicular. They are just reciprocals. 1/4 versus 4/1. It's the most common mistake in the world on this problem. The hardest part about this whole section is that students just get the wrong idea. These problems are easy if you work carefully. These problems are easy points to get if you work carefully. There's a process to memorize, but if you memorize that process and work carefully, you will do right. You will do great on these problems. Do everything right. If you fail to memorize that process, you'll always just make a negative sign here, and you'll just not hear me when I say they are not opposite reciprocals. They are just reciprocals. All right, whenever we state this rule on the box, the bottom of your paper, people get bogged down in the details, okay? Don't worry about the details too much. In the next video, we're going to go through how to use this rule. But just to close out this video, since slope is a change in y over a change of x, and since inverses switch x and y, that's another way to remember that inverse functions have reciprocal slopes, not opposite, not opposite. So with one notation, if a comma b is a point on f, then BA is a point on F inverse, and F inverse at that x coordinate is 1 over F prime at that original x coordinate. Another way to say it is if F and G are inverse functions, then G prime of x equals 1 over F prime of G of x. I think this is really confusing. I think a hybrid of these two is more helpful. So using this notation, if f and g are inverse functions, we have that g prime of b, that's what that's saying, equals 1 over f prime of a. That's the idea. If a and b is a point, that's all this is saying, because it would be g of b. G of b is a. Okay? We're going to just find these slopes. We're going to do a nice table. It's going to be much more simple in the next video. One reason this should work is that if f and g are inverses, then f of g of x equals x. This is a proof of this idea. You could always derive this if you got stuck. If you differentiate both sides, you would get the chain rule on this side, and as I said in one of the videos, this unit, I'm going to keep trying to show you the chain rule as often as possible, equals the derivative of that side. See? Okay, so that's a proof of this formula. That's the proof that it works. What do I want you to take away? Just that. Okay, if we want to find the g prime of a y coordinate, basically, we would do 1 over f prime of the a coordinate. Derivatives of inverses have reciprocal slopes at their image points. When finding the derivatives of inverse functions, do not use the same x value for both f and f inverse. This will not work. 99% of the time. They are literally going to be testing you about whether you think that works or not. So be smarter than that. Do not use the same x value. Use this formula. G and F are inverses. It'll clean up your notation a bit. Right now, you should try 1 through 3 on page 143. If you try those problems and do them all, it's basically this example 3 times, you'll have a much better handle on that they are reciprocal problems, not opposite reciprocals. Thanks for watching this video. Good luck on those problems. Ask me if you need any help. Have a great night. Have a great day. Bye.